of a formal presentation. I am just here to share my research experience that I did in these two fields. So social application, basically, I will be talking about my past 2 years experience on fake news classification and detection. So it is more on disinformation detection and industrial application. I worked with some of my colleagues in University of Klagenfurt, Austria. As so, I was there for 2 years as a postdoctoral researcher. So I spent time with those guys from different countries, and our job was there just to make some intelligent applications that can give the real life experience while streaming the videos on OTT platforms like Netflix, Amazon Prime, or any other OTT platform. Like in India, we use Sony Live or Hotstar. So, means I will just spend almost 1 hour on these experiences which I gain in last 2 3 years during my research. So first of all, like this is just a brief introduction, like about the research domain of AI, artificial intelligence. Like machine learning, it is very prominent nowadays, and even one step ahead from machine learning. Now people are talking about deep learning or explainable AI, and people are talking about federated learning. So these are the research domain nowadays that people are working a lot. Neural network, it is somehow the fundamental of deep neural network or deep learning. So this is another research domain. Robotics, yes, this is also one prominent area where lots of research is going on, and people are actually involving robotics with IoT to make some intelligent applications. And if I talk about like uh, uh, smart cities and we say like smart devices, lots of robotic and IoT combination is involved over there along with the blockchain methods. So expert systems are there, fuzzy logic, and natural language processing. So these are some research domain which are more or less related to AI. So AI is the broader term. So my focus is on AI related things. So there are two applications that I will give the brief about. So one is fake news detection that comes under the social application, and one is video streaming, which is purely the industry application and having lots of commercial benefits and commercial attraction of the companies. So, like very common question from every one of you, like, do you always believe everything that you see online? And I'm sure that you will be saying no. And yes, definitely, whatever we see, especially on social media platforms, we can't actually blindly trust on each information which is circulated over there. Nowadays, sorry, nowadays what happens, like everybody is having the access to circulate anything without any checks, without any proofs, without any facts, and without any authentication. And means everybody is behaving like a journalist. So any information that comes in the mind, or any influential information which is coming for the circulation, people are intentionally or non-intentionally uh, being a part of that particular uh, unethical thing, and it is actually very harmful for the society also. So, means how do you tell as a common man if something is true or false? So there are three things that firstly come in the mind. Like if anything which you disagree with, automatically you will say, okay, if I do not agree, it will be definitely false. Second would be like articles that paint someone you admire in an unflattering light. So let's say everybody is having uh, some kind of means basic behavior, and they also have some liking and disliking. So if anything which is not anyone's like we say like in the favor of anyone, then automatically it would be considered as a false information. If I take an example of any Bollywood actor, so if you like some Bollywood actor, and if any news is circulated over the social media, and it is against that particular actor. So at the first instance, it would be very difficult to you to accept that this is the real information. Okay, so from and also another important thing to that help you to recognize whether the information is true or false is just the information which is coming from the source, if it is showing one side of the political spectrum also. So like uh, regarding the celebrities, regarding the political leaders, lots of fake news information are being circulated on social media. So never in the human history has more information being available to more people, but it is also true that never in the history has more bad information being available to more people. So yes, as in India, especially if I talk about, like, we are in the democratic country and everybody is free to circulate anything, but as a Indian citizen, it is our responsibility also just to be very a responsible citizen. Before sharing anything, we must be very confident whatever we are sharing in the social media, that must be very authentic and true. So like because nowadays, like, everybody is having access to circulate anything, and means my voice is has a reach in the uh, global audience. So it doesn't mean that I will behave like a journalist. So until unless I am not very much sure about any information, I should just refrain myself to circulate that information. So there are different websites. So fake news website deliberately publish the hoaxes, propaganda, disinformation, and that purportedly to be real news, and often using the social media to drive the web traffic and amplify their effect. So if I talk about like this scenario, fake news, it that particular term became more popular at the time of 2016 US presidential election. At that time, lots of fake news information was circulated in the market and those US elections were directly influenced with those kind of fake news information. So the formal definition, if I talk about the fake news, it is the low quality information with purposefully false data, and that propagating by individuals or the bots that deliberately manipulate the message for title or political plans. So here we can see the kind of this share. This is the generation wise share. So these are the age groups. So 65 plus age group, and means basically I'm categorizing the entire groups into two categories: less than 50 and more than 50. So here you see that in more than 50 people, 50 years old people, like, they are categorized that they are sharing in a cable network, local cable network, or network
Excuse me,
TV.
sir.
Yes, yes.
Might be my slides are not working, or it's not actually turning the your slides are constant.
Okay, okay, okay. Oh, I need to try it again. All right. Give me a minute. Whether you can see slide number 8.
Yeah, it's why does fake news spread so much? We can
Yes,
see this
yes.
slide.
So I'm just making it in full screen. So please confirm whether it is
Yeah,
visible
yeah,
to you.
it's in full screen now.
Okay,
Yeah, it's
fine.
working. It's working.
Yeah. So here I was talking about this generation gap graph. So there are two categories broadly. One is less than 50 years age group people, and one is 50 plus years old people. So here you can see, like, the almost 75% of 50 years plus old people, they are preferring the cable network TVs, and here you can see that almost 48% of this share and 23% of this 50 plus years. So total here on an average it would be around 35% average. So they are depending on the print newspaper. But the young generation, they are referring the websites, mobile apps, social media, and here you can see almost 50% people of both the group up to 50 years. And here also you can see like 14% of the youth, young generation means these are the teenager people or just we say like entering into the adult group, and youth people under 50. So their share is almost for 24% here and 14% here, average is almost 20%. So the majority of the youth is actually referring the websites, apps, and social media. It means one thing is very clear that globally the future is of these news and the kind of information sharing would be through this particular medium, websites, mobile apps, and social media. So and this is actually open platform, publicly available for everyone to share the information, just to use that information. So we need to be very much careful, and we need to just guide our children's in a way that they should not be misled, or unintentionally they should not be part of that particular spreading the fake news. So here why that particular news fake news is spread so much. So here there are some research that says that more than 60% says that the action they took upon seeing something online was to share it with friends and family. So sometimes you have seen also like anything that is circulated to you on any of the social media platform, either it is WhatsApp or it is Instagram or it is any other platform. You see like something is being circulated, and sometimes intentionally or intentionally we circulate it to other people also, and even we do not know that we are the part of that particular thing which should not happen, but we become the part of that. So there are various sources of fake news is spread, like open social network like Twitter, Facebook, YouTube, WhatsApp, Instagram, Reddit, Telegram, online blogs. These are there, and here there are some statistics. Here you can see like Facebook and Twitters. These are the top pioneers, market pioneers, who are facilitating over 1.3 billion clients with a dynamic monthly variation of 300 million users in average. So almost one India, complete India, they are having in virtual environment. So you can just see the impact of this open social network, and also you can understand the kind of impact of fake news. So there are basically three types of fake news mainly. Audio based is also there, but primarily the fake news would be either text based or image based or video based. So if I talk about the can be either just fake information, anything which is wrong, which is not actually correct and circulated. That can be one type of category. Another can be like satire. Satire can be a kind of prank which is done just for the fun. Sometimes people do not actually check the disclaimer of that satire information, and they sometimes believe it as a real. So that is another type of information. Misinformation, this sometimes we call it as half cooked information. So half cooked information means some true facts are hidden, and the half truth information is circulated with wrong intentions. Rumors are some kind of information spread which is intentionally shared among the people just to create some kind of chaos. Hoax is a combination of misinformation and rumor. So it is also a kind of disinformation. Also, disinformation is a broader category that covers misinformation, rumors, hoax, satire, and fake news altogether. propaganda, mostly these propaganda, this term comes from the political background. So like politicians, they actually set some propaganda, and there is a popular term toolkit nowadays. So there are some propaganda points, and people are intentionally circulating that just to defame something. And opinion span is a kind of like there are some like you have seen in the news debates, in the audience there are some people who are actually very like we say, their faces are very fixed, means in all the news events you can oftenly see those faces, and they have their particular opinion, and they ask the questions and queries, and try to create the environment over there, just to actually favor someone or just to defame someone. So these are some examples of a decontextualized news example. This is for the COVID-19 era. So this is half-cooked information, means the message was in different context, but it was circulated for general people. And this is another example of false news, where some information which was actually written over there on the Twitter from the blue tick account of former president of US, which was considered as the fake news. So there are some fake text information also you often see, like you have received some SMSs, or you received some mails where it is written, okay, congratulations, you have won some lottery of XYZ amount, and please fill this form, and you will just receive a call, and then the amount will be transferred. So these kind of messages are completely the fake messages, text messages. So we should actually refrain ourselves to avoid these messages. So there are some text based fake news detection methods. So these methods are prominently are text-based features, user account-based features, linguistic-based features. TF-IDF is one popular approach that we use in NLP kind of application. So it is also used for fake news detection in text-based data. And temporal and propagation-based features. One by one, I will actually tell you how does it work. So knowledge-based study is one primary method that in which some information is there, and that information is written in some natural language. So what you do, you just classify it some using some grammar rules and extract the subject, predicate, object. You search those keywords on some authentic web sources, and after searching them, you find some websites or web links or some news portal sites, and then you just identify whether how many of those websites are claiming it as a real or fake. So based upon that judgment or based upon that voting classifier, you decide whether the news is real or fake. This is knowledge based study. Another comes the style based study. So this is the writing style of that particular information. So in that way, you can develop a model, AI model or intelligent model, where some kind of pattern style, writing style patterns can be analyzed using some primary attributes, and then it will help you to decide whether the information is real or fake. Propagation based study, it says like usually based upon some previous research and survey, it was found that the fake news which is intentionally generated and circulated among the people has the high impact in circulation, and it requires less time to circulate among more people rather than the real information, because the intention of that fake news was just to spread it more and more. So this is a kind of study, propagation based study. So this is one important feature that you can consider to analyze whether the information is real or fake. And fourth is the credibility based analysis or study, which says uh, the message text or the topic which is written over there, whether it is credible or not, or and as well as the user who is sharing that information, what is the credibility of that user, whether how many followers that person is having, or we say whether that profile is blue tick profile or authentic profile, or also in the past, what kind of historical analysis is there about that particular profile, means whether in the past also such kind of fake information that person has circulated or not. So based on these kind of analysis, we can also identify whether the information is credible information or non-credible information. So there are different methods, machine learning and deep learning methods, that we can refer to analyze and detect the fake news. So naive-Bayes, decision tree, logistic regression, support vector machine, these are the machine learning classification methods that are very popular in this domain. And LSTM, RNN, and CNN, these are the deep learning models which are also popular for detecting the fake news. So there are some popular data sets that can be referred. So like BuzzFeed political data set, it contains 120 articles. Liar, it contains 12,800 articles. News SFN 2014, it contains 221 articles. Kaggle FN fake news, it contains 13,000. So these are different type of means data sets which are publicly available for research purpose. So people can use them and propose their model. So for spam detection, for hoax detection, for disinformation, misleading. Similarly, there are some approaches also to deal with the text fake news. So like linguistic queue approach is a method where some machine learning models and network analysis are used on the linguistic queue. The strength is that we can get the high accuracy, but the weakness or limitation is that it is suitable for the limited domain. It cannot, like domain means like financial news is there, or political news is there, sports related news is there, or means entertainment news is there, or medical news is there. So you need to fix the domain, and then only it will work on that based on the linguistic queue, because it is some kind of key, there are some kind of keywords that work uh, to analyze the data. So second is linguistic text and word pickup method. So means where some linguistic inquiry and word count are there, and in that proportion of words you classify your data and identify whether it is real or fake. So here it supports multiple feature set like analytical thinking, emotion tone, function words, pronouns, effective and social processes. So it covers many aspects to detect the fake news and real news, but the weakness is like it restricted to text domain only and not suitable for images, video, or any kind of mixed content. So similarly, if I talk about the deceptive opinion spam model method, so in that it uses visual feature for describe the image distribution characteristics and reveal the hidden distribution pattern of images and statistical feature for image content. And strength is that the accuracy is actually boosted by more than 7% in compared to the baseline approaches, and uh, weakness or limitation is like it feature of text are not used in that. So text news classification using kernel-based hybrid support vector machine. So in that case, some propagation-based patterns we analyze. Like as I told you, propagation-based means how fast information is traveled and what kind of sentiments are there of the public about that. So it achieves the higher accuracy up to 90%, but it focuses primarily on the rumor type information only. So multiple logistic regression method, the strength is like it develops the feature so that examine the headlines or the title and its agreement with the claim, and it doesn't access the whole article and the content of that article at the same time. So using LSTM, so LSTM long short-term memory, where this is the actually advanced version of RNN, recurrent neural network, where different gates are there. Input gate, output gate, forget gate are there. So there are some recurrent edges that actually again and again analyze the data, and based upon the previous historical information it propagate to the next level, and then it detect the results. So strength is instance detection tool can be incorporated into a large automatic fact checking pipeline work, and limitation is that more parameter tuning is required for better accuracy. And spotting the fake consumer reviews, in that case, like some kind of hierarchical credibility propagation based model with iterative algorithms for global optimal solution to initialize all entity with credibility values are used. And strength is that they are better than the baseline methods in terms of accuracy and average score. And limitation is that they work well only for the micro blocks only. So means for different types of platforms, different type of methods are there that works well. So similarly, bimodal distribution and co-bursting in review spam detection. So they say like credibility analysis model for computing the credibility of linked set of multi-type entities are there, and strength is that they perform better in terms of accuracy as compared to the basic credibility analysis. And limitation is that deep semantic parsing of tweets is not efficient. So adversarial neural network is also there. So it is a similar to the GANs. So generative adversarial neural network is there. So end-to-end framework named as EANN, Event Adversarial Neural Network for unseen events. So this is a method which is actually best suitable for multimedia data set where some video and textual information is there, and limitation is that they do not include the event discriminator. So the solution of this is GAN, so generative adversarial network. So here there would be a generator, there would be another discriminator, and then discriminator is trying to recognize the fake and real news from the generator, which is generating the fake information by itself. So such kind of models people are actually using nowadays for creating the fake news related to videos. And also GANs are also used to detect those fake videos. So this is most powerful tool for visual data. So now come to the fake images. In fake images, what happens, like usually, see, you can see these faces. Actually, these faces are actually the, we say, created faces. These are not the natural faces. So all the images are artificial, and they are actually generated by combining 2 3 faces of different celebrities. So there are some popular research data in image data set for fake news classification, like celebrity data. So this is for celebrities. So more than 200,000 celebrities fake and real faces images are there. ImageNet, more than 1.4 crore real images are there. And Coco data is there that contains 330,000 real images. So there are two popular methods like image splicing and montages. So here you can see like these two real images are there. One is this, another is this, and after combining them, they are creating a similar kind of image which also look like very true, but it is not existing anywhere. Similarly, here you can see the two people are sitting over there, Germany Chancellor and daughter of Donald Trump. So they are sitting all together and here in a meeting, and here you can see another separate image which is purely independent of this event, and people have actually splices the image, and it looks like that it is a real image. Similarly, here two different events are there. Okay, and after combining them, this is image montaging, where it looks like there's some transformation of one image is also done, and it looks like that in that that particular car is digging into that area. So here, face swapping is another powerful method that people are using nowadays, and also face swapping is also used to recognize whether it is a real face or fake face. So here, two celebrities are there, person one, person two, and after combining their contour points of their faces and examining their similarities and dissimilarities, a new face is created, which looks like very true, very real. So now come to the deepfake. Deepfake is more related to the video. So deepfake is a new technology that uses the artificial intelligence to create the fake videos, and with an application that can be downloaded, images are used to teach the AI to imitate a face. So when it is done, the software can insert the face in any of the video, and it is very powerful technique for machine learning and AI to manipulate and generate the visual and audio content with a high potential to deceive. So the first instances which were actually identified and become very popular and widespread over the internet, they were about the Emma Watson. Okay, she was she is the actress, Hollywood actress, and another one is Katy Perry and Scarlett Johnson. So and Barack Obama. So means these are some popular personalities, and some fake videos of these personalities were released over the internet, and it was very hard to believe whether these are the fake videos, because they were look like so real that it was hard to believe. So and after that, it such fake events have fake video and deep fake came into the picture, and in this particular topic attracted the scientific community to work on this to detect the deep fake. So here you can see like this lady is replacing the face of this original face, and it looks like that this is the real video. And another, here you can see like this is one face, another face using the, this is the auto encoder approach, where after training the images of two different individuals, a face is being trained over there. So auto encoder, there is one encoder, there is one decoder, and it is getting processed like this. So original face of A is there, B is there, and they are actually processed all together in encoder, and they are interlinked all together, and we are getting a negative photo, just like the negative film we have of any photograph. So these are some latent faces are created, and these latent faces are decoded again to create the original faces. This is the reconstruction phase. So remember here, this reconstruction phase is not same as the actual original face, but it is very much similar to the original one. So now what they are doing, this is the auto encoder job. So now original face is now processed to the decoder of another face. So after, sorry, after encoding it, then again the latent face is created, and that latent face A is processed to that decoder to create a new reconstructed face B from face A. So this is a kind of overlapping that they are doing. So this is one small video, which is a YouTube video. So as time doesn't permit, so I will just skip this. And this, it simply tells me how does it look like real, but actually the images are fake. So in this deepfake era, every woman is a potential victim. So lots of incident had happened in the past. So lots of means porn videos of fake celebrities were circulated on different communities, and therefore it is our as a scientist of AI domain, it is our ethical and moral responsibility just to work in this domain, to just protect the society. And here, how does it work? Like there are some DNN models, deep neural network model, and they create some models in a way that first the neurons, interconnected neurons, they actually linked all together, and they train the machine in a way that the face of one person and different dimensions of that face of one person is uh, trained, and then they try to copy the similar features and dissimilar features just to overlap them all together so that it look like very genuine. So who are the producer of this these kind of bullish work. So communities of deepfake hobbyists, they are actually responsible for this. Political players such as foreign governments or various activists, malevolent actors such as fraudsters, and legitimate actors such as television companies. So they uh, actually sponsor these kind of events and the activities among the society to defame someone. How we can combat with this deepfake? So there are some legislation and regulation also. Corporate policies and voluntary actions are there. Education and training, anti-deepfake technologies are there, deepfake detection methods are there, deepfake prevention methods are there, and content authentication. So like challenges are like 500 hours of content is uploaded per minute on YouTube. So means lots of data is there. So it is very challenging just to analyze and just to filter out the fake data. And Twitter struggles with 8 million accounts a week that attempt to spread the content through manipulative tactics. So this creates the massive challenges for technologies to go through all the posted material in a short time. So sometimes fake news get more views than the real news, and sometimes politicals and professional journalists even quotes the fake news stories. So even they are the blue tick users, they are having high fan following, but unintentionally sometimes they quote the fake stories also. So and also people engage in illegal and violent behavior as a result of believing on the fake news stories. So there are some popular fake news data sets that can be used for continuing the research in this domain to detect the deepfake data. So more than 800 real and fake videos are available publicly. Uh, it is Kaggle dataset. Deepfake data challenge by Facebook. It contains more than 120,000 real and fake videos. And face forensic dataset FF++. It contains 1,000 real and fake videos. So in deepfake video detection, as I discussed about that GANs. So GANs actually they can learn to create the word similar to our own in any domain. For instance, images, music, speech, and prose. So, however, they are also able to generate the fake media content and represent the technology underpinning the deepfakes. So, how does it work? It contains two neural network. One is generator, and second is the discriminator. The purpose of generator is just to train with the sample images and the video with the discriminator classification, and based upon the feedback that it learns, the true data distribution with the goal to fool the discriminator. So generator's job is just to generate the fake data in such a way that it can be bypassed by the discriminator and it cannot detect that data cannot be detected as the fake data by the discriminator. While the job of the another network that is known as the discriminator, its job is just to uh, it learns to classify the samples of true and generated data with a goal to shed the generator. So here, like different LSTM and CNN models are used to detect the fake news information on videos. And here also some BGG and some other CNN models, 2D CNN models are used to classify this data. What are the different efforts that society is actually doing? Means research society, especially in AI community, to combat with these fake news. So even in multiple different countries like France, Germany, and other European Union countries, in collaboration with the leading technology and social media companies, they are taking the action against the fake news phenomena. So these are some legal actions that they are doing, and there are OSN player like Facebook, Twitter. So they are actually creating their IT bots. Their job is just to detect the fake content on their database. So media organizations, they are also taking some initiatives for tackling the rise of fake news, especially in US and UK. And There are different companies like, as I told you, Google, Facebook. So they are tackling the rise of fake news by using some AI models and methods. And there are some online websites also, factcheck.org, ABC News, PolitiFact. So these news are actually helping us to categorize whether the given information is real or fake. So, spreading the misinformation or the false information or mischievous news is a punishable offense in India, and there are different Indian penal codes against that. So I will not go into these details, but yes, there are proper law and regulatory uh, means IPCs in India, Indian law. So as a responsible citizen, it's our duty just to not to be a part of such activities directly or indirectly, as well as we need to just guide the other people around us to just prevent themselves from these kind of activities. So there are some computational methods to handle the fake news also. So they are the researchers, they are trying hard to develop the devices and software to detect the and neutralize the fake news. If I talk about the text news, so lots of natural language processing machine learning methods are there that are very helpful to detect the fake news in text data. For image news data, computer vision, convolution neural network, deep learning methods, they are helpful to categorize the fake news in images. And for video news data, DNNs, GANs, ensemble methods, autoencoders in 2D and 3D, ensemble methods on 2D and 3D convolution, they are very effective and popular. So there are a few tips to avoid the fake news. So before spreading anything, we should actually evaluate the CRAP. CRAP means currency, relevance, authority, accuracy, and purpose. So currency means whether the information is current or not. So many times what happens, people actually spread the information of a very old event or instance, maybe 5 year, 10 years old instance by saying that this is a recent incident that had happened. So we need to first check the whether that is the current event information or not. Second is relevance. Relevance means if whether that information is really important for your research need or not. Authority, who is the author or publisher or the sponsor of that news, who is sending this. And accuracy means is the information supported by some evidences or it is just a statement. Purpose, what is the purpose of that news and what is the outrage. And to call to action, to inform, to sell, and this can give you a clue about the biasness of that information. Second, you can, before spreading that information, you can Google it, and if you find any authentic news source in support of that, then only you should proceed. Otherwise, you should actually flag that information there only and delete it. So distinguish the opinion from the fact. Even news programs have shows the uh, dedicated to the people's news opinion. So means in that opinion and facts, please do not trust blindly about those facts and opinions. So watch out for the red flags. Like there are some websites, if URL like .co or .com, in spite of .com, if any information is coming from .co or from any other unauthentic website, please do not believe on that. Are there small disclaimers or sometimes any satire is there? So please uh, check that and then only react this. And is it posted by so and so? Because on our social media platforms, definitely one or two friends on our social media group would be there who are actually involved in these kind of activities. So we need to prevent ourselves from that. Now I come to the industry applications. So, Shavir sir, should I continue? Means it will take 10 more minutes. So, will you please allow me for that?
You can, sir, it is up to you, sir. Can if you want some time, you
Yeah,
can
yeah.
say.
Means it will hardly take 10 more minutes. So, I will finish the another application that is transporting time prediction. So, this is another my research domain where I worked in last 2 years. So, in that, what I did, like this is one SCIE indexed paper in cluster computing. So fast approach for video transcoding, time prediction, and scheduling for HTTP adaptive streaming video. As I told, as I shared already at the starting, like what happens like on different uh, gadgets, electronic gadgets, the media files, different media files are required. So for example, like a particular video file extension which is supported on smartphones might not be supported by the smart TVs or CRT or LED LCD devices or laptops or desktop devices. So what happens like some kind of transcoding is required. So video transcoding uh, is uh, is to transcode or encode the video files from one type to another type. There are few popular transcoding. 4K is one. I just come to that. So 4K is one. X264 is another encoding medium. X265 is another type. So these are different types of encoded video files. So for which type of device we are using, it depends upon which type of means encoding we require. And every encoding is having its own advantages and disadvantages. So here, our approach was just to first collect the video sequences. The raw video sequences were there, so we collected that and then we created these small segments. So what happens like on YouTube, you have often seen like when you click on play, what happens, there are some on that timer track, there are some yellow color dots. Those yellow color dots actually says that that particular portion of the entire video is downloaded already during the streaming. So what happens like in that streaming, the entire video is streamed in the form of segmentation, small segmentation. So those segmentation can be of 2 seconds, even 4 seconds, 10 seconds. So what happens like means like this is the industry application. So when I talk about any industry, uh, the ultimate purpose of any industry just to gain more and more benefit by selling their product and also just to satisfy their customers so that they can retain their customers for long period of time. So quality of experience, QoE, quality of experience of their customers and quality of service to their customers. These two are the primary agenda of any industry, okay, that they want to keep up always. So to maintain good QoS and QoE with their customers, every company is trying hard just to provide them better services but with least cost in terms of time and money. So means if the services would be cheaper and quality would be better, definitely all the customers will be attracted. So our job was there just to predict the to perform that transcoding faster, and to make that transcoding faster, first we must be aware about the transcoding time, and for each segmented video how much time it will take to transcode it, and in total how we will segregate it on different servers. When I say servers, like what happens like each big company is having their multiple servers at multiple locations. For example, one server like Netflix is there. Netflix is one popular player of OTT platform. So if I talk about Netflix, so Netflix might have their server, 2 3 server in India, few in Europe, few in US, in Canada, in Australia. So what happens like as nowadays we are globally connected over the internet. So even we do not know from which server we are accessing the data. As a user, our job is just to get the information. From where the service provider is providing the data, this is not our job. And service provider, what they are doing, they are actually trying to provide the data. Means once as a customer, if I click on a button, immediately the service should be provided to me in real time. So due to the different time zones and due to different means uh, we say geographical differences, what happens some here in India it is a daytime, so in US it would be night. So what happens, like the servers which are at US, definitely US people will not be using those services. So might be some of the services that we are using, those services are coming by the service provider from US servers, not in Indian servers. So in that way, we need to manage the things also. So the scheduling, the job of that fast scheduling is just to identify those servers which are less loaded, and they can provide the entire job. They can complete the entire job in real time with or lesser time, so that customer need not to wait longer. So for achieving all these objectives, what we did, first we just identified video sequences, we segmented them using some online tools, some software tools, and then we extracted some features, we created the data set, and then we performed some AI modeling, some neural network trainings, and we perform the testing and validation also, we tune that data, and then finally we schedule that data. And after scheduling we found that if there are 50 servers involved, 50 machines are involved, then what will be the total execution time? If 10 machines are involved and those 10 machines are all are busy, then how much waiting time needs to be required? So turnaround time is calculated, and in terms of time span and other parameters we calculated, means what is the least time which is required for a customer to wait. So there are some work that we did in phases. So like these were those videos that we actually tried, and different parameters, frames per second means how many still images frames. So means, as we know that video is a combination of different frames, image frames. So 30 frames per second means 30 images are passed on in 1 second, and duration of that video is 60. So total frames that we are using for this first video is 60 into 30. So how many frames I am having here? 1800 frames. So this is the total characteristic of the original video files. Then we worked on the spatial information and temporal information of different video, and we found that how they are behaving, like depending upon their nature. So video category is there. So video category is identified based upon their patterns. And then different video codecs, as I told you, for encoding we require X264, X265, 4K, other kind of video files. So we did that. Different bit rates and resolutions which are very popular in the industry, we actually did this. So it is, yeah, this is very important, bit rate, because 20,000 bit rate with this resolution, if you will use it on your smartphone will be hanged. Okay, so for smartphone we always refer the low bitrate and low resolution, while for smart TV and HD or UHD smart TVs we always go for the higher values. If the bitrate is very high, bitrate is high means the transfer rate is very high of the data and resolution is also good, then we go for the better type of bit rates. And different segments are there that we classified in 2 second segment and 4 second segment. So we tested it on also the different encoding presets, their speed, basically encoding presets are there, transcoding speeds. So on different speeds we actually transcoded them, and these are 82,000 total transcoding were there, which were of 580 hours data. And then we actually categorize them in, and these are some prominent features that we use to train our model. And after training the model we found that these are the original segments. Then segment with low resolution we tried. Why we tried it at low resolution? Because the speed at low resolution, bitrate and low bit rate would be faster than the actual images. So then we calculated the SI and TI here, spatial information and temporal information we calculated, and we added that parameter over here to classify their complexities. So their complexities are classified for SI and TI values in that way, and we found that this is high temp TI and low SI. This is low TI and low SI, low TI and high SI, and high TI and high SI. In that way, we actually transport categorize all the classes. So these are the complexity classes that we did, and then we train our model and including those complexity classes. And these complexity classes values, these dots are coming from this data. At low resolution, we did it. So here you can see like the correlation coefficient between the encoded video segments with low resolution and the original video segments is 0.98 for TI and 0.65 for SI. So which are very highly and positively strong correlations. That's why we did it at the low values, and so that it can be faster and it will not hamper the overall time performance. These are the details of all these input parameters that we used, and we found that the performance is like for X264 encoding, the actual transcoding time for each category is like this. And interestingly, you can see like for these categories, X264 is quite faster than X265, and also the similar pattern means LL is faster than LH, which is faster than HL category, and which the slowest one is high TI and high means high TI and high SI. So in the same pattern, X264 is also giving. So after making that analysis, we made some kind of complexity analysis and calculated their mean absolute error and mean squared error, and we calculated it, and we found that we could achieve the mean absolute error up to 1.37 seconds, which is quite ignorable for the entire data of 80,000 plus entries. And here we could I can conclude here like with all these patterns and analysis, uh, and there are here the maximum time saving that we could do for 2-second video segments is 36%, and for 4-second video segments is 38%. Now you can imagine like if any uh, service cost means for example, if I talk about AWS, so AWS Amazon Web Services, their on demand service cost and EC2 instance service cost, they are around 0 0.1 or 10 cents per hour. And if we can save 36% on an average 30%, let's say, so now you can imagine that the cost would be 7 cent only. And in bulk, if I talk about for whole day, then 24 hours it is working, then it would be around $1. And if we are taking the services of multiple servers, so for each server, if we are daily saving $1 and we are taking the services of 1,000 servers on daily basis, then $1,000 we are saving without compromising with the quality. So this is a kind of summary that we did, and we made some various analysis on different presets, on different type of scheduling algorithms. Also, these are different scheduling algorithm that we tried: max min, min min, OLV, opportunistic load balancing, round robin. So these methods we tried, and we found that how well we are performing, and we compared our predicted transcoding time with the actual transcoding time, and we found that the patterns are almost similar, and the scheduling is done in a very accurate manner. So here, and this graph says about the actual transcoding time and predicted transcoding time, and here you can see number of cores are the number of machines or servers that we are using, and you can see that the predicted time scheduling is also giving the almost similar pattern as we are getting from the actual transcoding time. But actual transcoding time will be first transcoded, and then we can decide which particular machine needs to be used. While in predicted transcoding time, we are predicting in advance, and then we are deciding which machine we need to use and how many machines we need to use. So this is the analysis that we did. Yes, this is the future work that we are working. So per title encoding optimization, already this work is done, and we have submitted one research paper also here. And to optimize the utilization of the Amazon EC2 instances and reduce the price and transporting time, we already completed that work, and we submitted the work in one SCI journal, and hopefully soon we will get some positive news. So this is the total work that we did. So these are the references and the projects on which I worked recently. So from the fake news classification, one of my paper is published in IEEE Transactions on Computational Social System, and one paper is in Springer Journal, and I am still a part of this Articonf. This is European funded Eurozone project. So I'm still part of that. So these are my contact details. Anybody who is interested to collaborate and work with me in any form, my WhatsApp number is there. My personal email ID is there, and this is the form. Anybody is interested, you please fill that form so that I can get your information, and in future we can collaborate in paper writing, in project proposal writing, in book editing, and in any other way related to research. Okay, so this is all from my side. Uh, anybody is having any query, please ask it.
Among the audience, if you have any query, maybe some of the participants may be falling in this particular domain of research. If you have any query, you can directly ask or post it in the chat box, or you can in future course of you can directly contact the sir for the sharing of your ideas in that particular domain.
So there's a quick feedback actually from my side. No questions right now, but this what you have taught about the fake video creation and fake image creation is
Yes.
actually new to me, and this was actually unknown to us. And you have also shared the different models how these videos and these images are created via smart systems, and you have also shared some methods to avoid get escape from this fake information. So that was a quick new knowledge to us. Thank you.
Thank you, sir. Yeah, I also try to share the online resources also. Some data sets were there. So text data set, images data set were there. So anybody wants to, yeah, anybody wants to refer that, you may please refer. And some of the research papers are also there, which are openly available. So you may refer also. And I shared my personal information. So anybody wants to connect with me related to these domain, means they are most welcome.
Sure, sure, sir. Once again, sir, thank you so much, sir, for being with us on this particular FDP. It was so nice. You have shared your heart out, what you have did in past so many years and in this particular domain. Thank you so much, sir.
Thank you, Shabir sir, for inviting me once again. I thank you, and also I thank you all the participants, okay, who patiently listen me, and
So maybe,
I'm sure,
sir,
like,
I will explain. I will introduce myself. I am on behalf of Shabir sir. My name is Jahangir sir. Jahangir. Basically,
okay,
I am doing
yeah,
PhD. My area of research is mostly blockchain.
all right.
Application area is IoT based, but so sure, sir. Definitely in future, I may require your help or your guidance as well.
Definitely, sir. Anytime, Jahangir sir. In times to come, like in future, because we are also working in blockchain also. Yeah, so lots of decentralized. Yeah, lots of decentralized applications we are trying, and federated learning is the AI domain in that decentralization.
Yes.
Federated learning. So yeah.
Yesterday, when I search about your profile, I find LPU because I'm a student of LPU. I did my MTech from LPU.
Okay, okay. All right. I think might be in last 2 years, actually, I was not in India, so we do not actually meet in person.
Yes, but I
Yeah.
very long back in 2013, I passed out from 2013 batch. So
Okay. So it yeah, it was nice to meeting you all,
thank you,
and
thank you,
thank you everyone. Thank you.
thank you so much, thank you so much. You can leave now, sir. Thank you.
Yeah, thank you.
Now, final call for the participants. Hopefully, I will inform you in an afternoon session. We will have an sort of a feedback session, interactive session of, as I told you, there will be a session, a test sort of, we have to go through that particular procedure. So it will be done near about at 3 p.m. So I will share all the details. No need to worry about when it will be available, where it will be available, whether it will be in the WhatsApp group or something else. So definitely I will share. You will come to know who will be the continuous parts registered, who have registered and who have been present in most, at least in most of the sessions. So definitely they will be able to at least go through that particular small session of sort of their acknowledgements, what they have gone through in these sessions, and definitely they will find in that particular session. I will just call this session off, and we will join in afternoon near about before at least 3 p.m. so that we can. Now I think we should stop this now.
Okay, sir. We'll meet by 3 o'clock.